So we're doing graphics, if you can see. Maybe I'm logged. I think this should work. Can anybody see? Hopefully this is working. Yes, I think we're good. Okay, so we're doing this graph frick worksheet. There's a graph and there's this. Before we do that, we should talk about rules. So I'm going to talk about rules first. Because anytime you have a graph frick, it's one of my favorite fricks because you don't have to do any math, but you do have to know rules. So if you know the rules, then you'll be able to apply them and you'll be able to answer the questions. So let's go over those first. Can people hear me? I think they can. If not, we'll see. Okay, so first rules. So I'm gonna write the main rules. So really, what's tricky about the graph rig is that it comes in two variations. The first variation is this, so we'll write this down. So variation 1, and then variation 2. And they're very, very similar, but I still keep them separate because it's easier to keep them separate in your mind. So the first variation is the variation that everybody's typically knows, which is that there's a given f prime graph. So this will be a given picture. You'll see the f prime graph on the page somewhere. And then secondly, there will be an f point. So you'll have this. And the reason why you have an f point is to do FDC in the future. So that's the givens of the first variation. For the second variation, we have this formula, where we have two functions instead of one, and we have g as an integral of f. So we're given this, including this bottom number a. And then what we do is we don't have to do FDC because there's an integral already on the page. We'll see this when we do this worksheet, as we're about to do. But instead of an f prime graph, it's going to be an f graph given when you're doing this variation. And the reason why is because g prime is equal to f, so it'll be the same thing. We'll have a derivative graph. Is anybody in the chat? I don't know if anybody's in the chat, but if not, that's okay. Okay, so let's go over rules and then we'll get started with the worksheet. So the rules everybody's typically knows. There's 4 main questions in these graphics with regards to shapes of curves and things like that. So let's write those down. We have f is increasing. That's the most basic rule. That's where f prime is positive. We have f decreasing. That's where f prime is negative. We have f for L max or local max, not absolute max, for example. That would be different. F for L max is when f prime goes from positive to negative. That's like you're running uphill and then downhill. F for L min is f prime negative to positive, going downhill and then uphill. The two trickier questions are concave up and concave down, and then function points. F is concave up when f double prime is positive. So keep in mind there's another rule for f is concave up, which is f prime is increasing. But in this case, we're going to do f double prime is positive. Sorry, there's 2 rules. F double prime is positive and f prime is increasing. Because we have a graph of f prime, we're not going to do the f double prime rule. We're going to do the f prime rule. So we're going to look at where the graph is literally going up or has positive slope. F concave down will be similar. Instead of using the rule that f double prime is negative, we're going to use the rule that f prime is decreasing because, again, we have an f prime graph. Same with inflection points. When you have inflection points, that's when f double prime changes signs. But a better way to phrase this is f prime goes from increasing to decreasing, or vice versa. We're almost done with the rules. So these are the rules for an f prime graph question. Again, that's the most typical variation, but there is this other variation that is very, very similar, but it has slightly different rules, so I'm going to talk about that. That's actually going to be our first question here on this worksheet. So for this variation, I like to start off with the question by thinking about what is g prime and what is g double prime, because inevitably they're going to ask that question. If g is the integral of f, that means that g prime is equal to f, and that's by the fundamental theorem of calculus. If you want to take a derivative of an integral, all you do is you take your upper limit x and you plug it into the function. And if g prime is equal to f, if I take another derivative, I get g double prime is equal to f prime. So these are not givens, by the way. This is really the start of my work. Anytime I have this construction of g having an integral of f or f having an integral of g, I just write down these quick derivatives because, again, I know that they're going to ask me some derivatives later on. And I like to think about how I'm going to find each of these values. Keeping in mind, we're going to have a graph again. So this g value is going to be area, because that's how you evaluate integrals when you have a given graph. G prime is going to be the y value. And you might think that it's going to be slope because it's g prime, but because the graph will be of f, it's going to be the y values because g prime equals f. And then g double prime is f prime, and f prime is, again, the derivative of f. So that's going to be our actual slope of our graph. Again, this will be more clear when we start these examples. So this is my construction, g prime, and g double prime. And the key one is actually g prime equals f. I'm about to write my rules again. We might just write the top half of the rules. But anytime I have a rule for this variation as opposed to this variation, I still need to talk about my rules and have sort of my question and justification. But every single time I'm doing this, the subject of my rule is going to be g prime equals f. And that's because I want to refer to the given function g and also the given graph f. So I'm going to write my rules down real quick. So we have this. So g is increasing. And it's similar to f is increasing. F is increasing when f prime is positive. So g is increasing when g prime, which is equal to f, is positive. So you'll notice that as I do this, I'm going to write g prime equals f, g prime equals f, g prime equals f, g prime equals f 1,000 times, because that's the justification, the best justification that they're looking for on like the AP exam, for example. G rel max or local max, same thing. It'll be f prime positive negative, but because we're dealing with g, it'll be g prime equals f goes from positive to negative. G concave up. We could use a double derivative rule, but because the graph will be of f and f is g prime, we're going to use this rule. So again, notice that everything is still the same, except instead of writing f prime, I'm writing g prime equals f, g prime equals f, g prime equals f. And lastly, for inflection point, we're going to do the same thing. So it's going to be g prime equals f goes from increasing to decreasing. I'm going to write INC to decreasing, or vice versa. We could versa. So that's basically it again. These are the rules all the time. This variation f prime graph given, this variation g given. We'll refer to this as we do the questions, but let's do a question here. So I have this question right here. This is my given graph, and notice that we are in the second variation because I have g is an integral of f, and then I have a graph of f. So this is my second variation. Maybe the variation that you're less familiar with. So keep in mind that it looks like we're going to have to find g values, g prime values, g double prime values. So that's why we did that work earlier, and we'll do it again. We have g increasing, g concave down, and we also want to find some other questions like tangent lines and things like that. So let's get started. So again, anytime I have this construction, I like to write on the side here, g is going to be area, because that's the integral. By the fundamental theorem of calculus, g prime is equal to f, because in order to take an integral, all you do is you plug in the x. Again, that's going to be our y value and not slope, because this graph will be of f. And then finally, we have g double prime is equal to f prime, and that's going to be actual slope. So we're going to just try to find and do this worksheet. Looks like we have 3 questions here. Oftentimes on the AP exam, they don't ask the same question back to back, like finding g of 1 and g of 3, but you'll see that there's a little bit of variation, so that they will do it in this case. So I'm going to plug in g of 1 here. So what some students struggle with is actually plugging in numbers in these questions. And all you do is you take g of 1, you're just going to plug it into the top here. Notice that there's an x here, an x here, and a t here, and a t here. So when I plug in 1 into my independent variable, the only independent variable that resides in the right side is this top upper limit right here. So I'm going to take my 1 and I'm going to plug it in right there. So it's going to be integral of 1 to 1. And what will remain is still f of t times dt. So I'm ready to do this. I'm going to plug in 1. And again, how are we going to find these? Well, this is going to be area. Because g values are going to be area. So I have to find the area between 1 and whatever number I plug in. So this bottom number right here is very relevant for these area questions, and they're less important for like number 2 and number 3. So when I plug in 1 for the first one, notice that I have the area from 1 to 1. So this is sort of a weird gimme question. This is actually going to be 0. I don't have to look at the graph because I know that the area between 1 and 1 is 0. So I can move on. Let's do something more exciting, which is g of 5. Again, I'm going to take my upper limit of 5 and I'm going to plug it into the top variable. So it'll be 1, 5 f of t times dt. And then I'm going to find the area now from 1 to 5. So it'll be 1 right here to 5. Just be wary of certain area rules. The area rules that you want to be aware of is that area over the x-axis is positive, area underneath the x-axis counts as negative. You have to have a bigger number on top than a smaller number when you're doing your limits, but here we have that, so we'll talk about that later. But again, we're finding area. And remember that the area, you don't find the entire area every single time, you can find it from 1 to 5. So I'm going to count boxes because it seems like that will be easier. For example, this is 1 box, this is 2 boxes. If you can do triangles like base times height divided by 2, of course, but it looks like if we like cut this out and like put it over here, we would have 2 more boxes. And then this one, if we cut this little triangle right here, we would have another box. So it looks like we have 5 boxes there. Now I'm going to do the negative area. Again, I'm going from 1 to 5, so I have to subtract off this little triangle right here. And that looks like it's going to be 2 boxes because I have this box right here plus 2 half boxes. So that's going to be minus 2, and that's going to be 3. Again, I'm just doing area. I'm going to do g of 0 on the bottom here. So g of 0 is going to be 1. I'm still going to plug in 0 into the top here. So that's what I'm going to do. F of t times dt. And again, we're now in a bad situation because the top limit is smaller than the lower limit. 0 is smaller than 1. So all you have to remember is that you don't do area yet, you do negative area. So this is negative area. And if this is negative area, well, we're finding the area from 0 to 1, which is this portion right here. So it's just these 2 boxes. That's going to be 2. But again, because we're doing negative area, the answer is negative 2. So hopefully that makes sense how we did these questions. Again, we just take each of these numbers, 1, 5, and 0, and then we plug it into our upper limit. We do the area, so we find the area from whatever number we plugged in to the given constant, which is in this case 1. If we plug in a top number that's smaller, we have to remember to flip the integral and do negative area instead. And if we don't, or regardless, what we're going to do is we're always going to find area. Area underneath counts as negative. Area above counts as positive. So that's actually the most difficult question probably in part 1 on this first side of this worksheet. Because if you do number 2, 2 is my favorite question, and it is less asked, of course, but we're trying to find g prime of 1, g prime of 3, and g prime of 5. And why is this question so much better than the other questions? Well, g prime is equal to f, and that's going to be the y value of our graph because we are given a graph of f. So all I have to do is look at y values. So this question will take not too long at all. If I go to 1, notice there will be 2. That's the y value. If I do g prime of 3, we can write f of 3. That's probably the best way. We want to get used to writing g prime equals f, g prime equals f. So g prime is equal to f. We're going to plug in 3. We're going to go 1, 2, 3, and that's 0. There's only 1 person in the chat, but that's fine. That's going to be 0. And then finally, we are going to do g prime of 5. And g prime of 5 is the y value right here, so that's going to be negative 2. So again, g prime values are easier than g values because g prime values are just y values. Second one, now we're going to do g double prime values. So when we have g double prime values, that's going to be slope. So that is a little bit harder than y values, but it's not too bad because all of these lines are pretty straight, I guess. So if you have g double prime of 1.5, let's write out the rule. G double prime of 1.5 is the same thing as F prime of 1.5. Again, we already did the work earlier where G is area, G prime is Y values, and G double prime is slope. So when you have G double prime is equal to F prime, that's going to be the slope at 1.5. So 1.5 is actually a little bit of a hard point. It's right here, if that makes sense. And what some students can't figure out is that they can't figure out the slope if it's like midway in between a line segment, but just keep in mind that the slope is consistent along the entire line segment. So if you have to, you can always do y2 minus y1 of the endpoints as opposed to that point that you were trying to find. But an easier way, especially when these lines are so straight, is to do rise over run. So notice that the slope of this line is going to be 2 because I rise 2 and run 1. So that's going to be 2. I'm going to do the same thing for G double prime of 4. So if you have G double prime of 4, it looks like this is my x value of 4. G double prime is equal to F prime. So G double prime of 4 is going to be the slope of this line. And again, you can just sort of eyeball it, or you can find the slope of this line using y2 minus y1 over x2 minus x1. This one is going to be -1 because I go down 1, run 1, go down, run 1, 1. And oftentimes when they ask these G double prime questions, they're going to ask one like G double prime of 5. We look at 5, it's right here. My graph has gotten a little bit cluttered, but notice that it's a start point and it's going to be does not exist. And why is that true? Well, you can't have two slopes, so you have no slope, I guess. So oftentimes when they ask these F prime values with a sharp point, they're going to ask one that doesn't exist. So before we move on to the rules that we talked about earlier, with all these shapes of curves rules of increasing rho max and so on, we're just going to briefly recap this. G values were area. Try your best with area with negatives. G prime values, which are F values, are going to be Y values. And then finally, G double prime values are going to be F prime values, so that will be slope. So let's move on. Let's do the sort of easier questions, the questions that don't involve any math. So let's get started. G is increasing. So anytime I have these questions, I like to write the question down, and then I like to write the rule before I do the question. Again, anything is increasing when its derivative is positive, so G prime is positive. But anytime I justify in these questions, I'm going to write G prime equals F, G prime equals F, G prime equals F. So I'm going to write G prime equals F is positive. So now that I know what I'm looking for in my graph, I'm going to be able to do the question. Let's look at the graph, actually. Just keep in mind when I say G prime equals F is greater than 0, you always focus on the rule as opposed to the question, because the question is about G, but the graph is F, and F is G prime. So we're going to focus on the rule first as we do the question, even if the question is about G. Hopefully that makes sense. So, for example, I'm not going to be looking at where this graph is increasing. I'm going to be looking at where this graph, because this graph is F, is positive. So if I look at this graph and where it's positive, it looks like it's from this portion right here to this portion right here. So it looks like it's going to be 0, 1, 2, 3. So it's going to be 0 to 3. And hopefully that makes sense. Let's do concave down, which is pretty similar. G is concave down. There are two rules for concave down. One of them is G double prime is negative, but I'm going to use the G prime rule because, again, my graph is of F and G prime equals F. So I just keep writing G prime equals F, G prime equals F, G prime equals F. And here, G prime equals F, the rule should be decreasing. So unlike last question, I'm going to focus on where the graph is decreasing because I always focus on this portion of the rule as opposed to this portion of the rule. So in this case, I'm looking at where my graph is, my given derivative graph will be going down or going like slope downhill. So if I look at this graph, notice that my graph is going down from this portion to this portion. It looks like it's from 2 to 3. And it looks, oh, it also goes down from here to here as well. I didn't see that. So it looks like, let's do our answer again. It starts at 2, and then it starts going down, starting from 2. So it'll go 2, keeps going down, keeps going down. So it looks like it's 2 to 5. So I'm going to mark my answer wrong and then write 2 to 5 instead. And that's how you do shapes of curves questions. We'll have opportunities to do Rellman or max questions or inflection point questions on the back. So I'm going to keep going with tangent line questions. So a tangent line. Tangent lines are very important in calculus, of course. The tangent line is where the derivative is equal to the slope. I'm going to write my tangent line and point slope form. So it's going to be g of 5, whatever that is. Sorry, I don't know what I'm thinking. It's going to be y minus g of 5, y minus the y value, which is g of 5, equals the slope, which is g prime of 5, times x minus 5. And I have 5 here because the question asked me about 5. And again, the word tangent means that the slope is going to be the derivative. So I need to find g of 5 and g prime of 5. And usually what I would do is I would take my number, I would plug into my function, and then I would be able to find the function value. Then I would take a derivative, and I would be able to find the derivative value. But in this case, we have a graph, so we're not going to be taking derivatives. But we actually already found g of 5 and g of prime of 5 earlier. G of 5 we found with area, so I'm just going to record what we found earlier. But again, what we did is we found it with area. So it's going to be y minus 3. We also found g prime of 5. And remember that g prime is equal to f of 5. And that was the y value of this graph, so that was negative 2. So this is my answer to my equation of my tangent line. Hopefully that makes sense. Now the most annoying question, absolute max or min. So anytime you're doing absolute max or min, what you want to do is you want to follow the 3-step process: locate, critical points, and table. So I'm going to write out those steps. Locate, well, it looks like we're trying to find it on G. So I'm going to take G. I'm going to just take it from the top here. So it's integral 2 to x f of t times dt. Then the second step is critical points. That involves taking the derivative. And what is the derivative of g? Hopefully by now you know that g prime is equal to f by the fundamental theorem of calculus. And the second step isn't just taking the derivative, it's also setting it equal to 0. So at this point, sometimes when you're doing abs, max, or min questions, you would be factoring. If you had a calculator, you might be using the solve button or graphing. But here we already have the graph already provided. So we just have to look at where this graph is 0. And it looks like it's this portion right here. I think I've colored this graph too many times and I'm a little confused, but I think this is 3. 1, 2, 3. So that's my only critical point. And now I'm going to draw a table. So it's going to be x values on the left and then g values, because that's my locate, on the right. So what numbers are we going to plug into our table? Well, we always plug in our endpoints, which are 0 and 7. And then we put any critical points that fit within those endpoints. So that's going to be 3. Now I'm going to plug my values into my function. So again, we're going to try to use our work from before. So we already found g of 0 at least from the top. And remember how we found it is we plugged it into the top of this integral and we did area. And we had to remember that we had to do negative area though, because 0 is smaller than 1. So that answer ended up being negative 2. Now let's plug in 3. And just like when we did in the first question, when I plug in any numbers into this integral, I'm finding areas, because this is how you find integrals when you're given a graph. So when I'm trying to find the area from 1 to 3, so 1 is right here and 3 is right here. So it looks like it's this portion right here. We already did that earlier. We were counting boxes. Again, you can break shapes up into trapezoids and triangles, but that ended up being 5. If you remember, if you counted these boxes, 1, 2, 3, 4, 5. And then finally, we had to find g of 7. It is annoying to find these areas, of course, but if you try to think about it, how you found the previous areas and you like tack on areas, if that makes sense, then it'll be easier. I'm going to do g of 7 in the top corner here. I still do it from the bottom number, which is 1. So I'm trying to find the area between 1 and 7. And we already found the area from 1 to 5. So that was 5 minus 2. Because it's 5, this portion right here, to this portion right here. So it looks like we have this portion remaining. And again, this portion of the graph is negative, so we're going to subtract off this portion. And I'm going to count boxes. It looks like I have 1 box, 2 box, and these 2 partial boxes make 1 full box. So it looks like I have 3 boxes. So it'll be minus 3. And 5 minus 2 minus 3 is equal to 0. So that's going to be my final y value. Now I'm ready to answer the question because I found this table. What's the abs max? Well, that's going to be our biggest y value in this table. That's going to be 5. And then what's the abs min? That's going to be the smallest y value, so that's negative 2. And we are done with this worksheet. At least the front side, because we have a back side remaining. Shouldn't be too bad, though. But just to recap, G values are area, G prime values are Y values, G double prime values are slope. Anytime you're doing shapes and curves questions, when you're given this variation with the integral, you just want to write G prime equals F, G prime equals F, G prime equals F. Equation of the tangent line isn't too bad because you probably already found the values. And then absolute max or min is probably the worst question. But what you do is you do your normal locate, critical points, and table. Okay, let's do the back. So here's the back. So this question, this variation, is the easier variation because it looks like we have G as an antiderivative of F. So when I write F here, I can write G prime here. And I'm given this point. So I'm not given an integral, but I have to construct integrals later on. But this is the variation I'm more used to. I have G and I have G prime. Just because they give me this F, I'm still going to write G prime equals F because why not? Usually the variation is, this is called F prime and the graph is of F, but we can still proceed. G is the given, G prime will be our derivative, G prime happens to be F. So just as practice, I'm going to keep writing G prime equals F when we do our shapes and curves questions later on, like concave up and inflection point. So first question, G of 6. So just be wary that you don't just plug in 6, you don't find the Y value because this graph is of F and not G. So in this variation, they have to give you this point that we underlined earlier. And the reason why is that you have to do fundamental theorem of calculus. We didn't have to do fundamental theorem of calculus on the front side because the integral was already sort of part of the givens. But when you're given this variation, when you have an F prime graph and a point, you're going to be doing FTC at some point, and usually it's one of the first questions, if not the first question. So how do we set FTC up? Well, we set it up the same way as always. We have G of 6, we have some sort of derivative right here, and then we have this point. So we try to think about how we're going to configure these three numbers, 2, -3, and 6. And the way it works is we have to add the Y value, which is -3. Then we put the given X value as our lower limit, which is going to be 2. And then we put our want X value, which is 6, on the top. Then we write the derivative, which in this case is F. So this is how you set up FTC. Either use X's or T's to be consistent. And now that I've constructed FTC, I do what I did in the on the front page. So it's going to be -3, and I'm going to have to evaluate this integral. But because this graph is G prime equals F, that means I'm going to do area for this graph. This looks like it's a little bit trickier of an area, so let's be careful. So this first one actually isn't bad. It's just this triangle right here. Keep in mind, I still have the -3 in the front, so it'll be -3 plus area. So it's the area from 2 to 6. So it'll be -3 plus 1, 2, 3, 4. 4 times 2 divided by 2. If I quickly do math, that looks like it's going to be 1. So that's going to be G of 6. Now let's find G of -4, which looks to be a little bit trickier. So G of -4. Well, it looks like we're going to do FTC again. Again, this is one of the only questions on the AP exam where they ask 2 questions back to back that are the same topic, and it's because there's a slight little nuance when we're doing G of -4. We still set it up the same way. It'll be the given Y value plus the given X value on the bottom, so that's still 2. And then we put the want X value on the top, -4. Unfortunately, we're in the scenario where we have a smaller number on the top and a smaller number on the top and a bigger number. What am I thinking? We have a smaller number on the top and then what are we thinking? A smaller number on the top and a bigger number on the bottom. For some reason, negatives just confuse me. But we have a smaller number on the top and a bigger number on the bottom. And usually when we're finding areas, we have the bigger number on top and a smaller number on bottom. So in this case, we have to account for the fact that we are not in the situation that we like. And all we're going to do is we're going to negate the integral. But oftentimes, students eventually stop negating the integral, and they'll just write minus area instead. So we're going to write -3 minus area. And then we're going to find the area between -4 and 2. And when we do that, we're going to be very careful with this minus. So I'm going to put the area in parentheses before I even get started. So my area from -4 to 2, will go within the side this parentheses. So let's do that. So it's the area from -4 to 2. Just keep in mind that we still have to abide by our area rules. Area above the x-axis counts as positive. area below the x-axis counts as negative. So we're going to do this triangle right here. I'm going to do baseline side divided by 2. It looks like it's 1, 2 times 1, so it'll be 2 times 1 divided by 2. And then we're going to find the area of the semicircle. Well, the area of a circle is pi r squared, so a semicircle would be pi r squared divided by 2. And then what is the radius of the circle, because that's what r is, that's 2. So that's going to be pi times 2 squared over 2. That's going to be 2 pi. But again, because it's underneath, we're going to have to count it as negative. So we're going to write minus 2 pi. Almost done, team. We got this. We're going to distribute this negative, so it'll be negative 3. Well, these 2's cancel, so it'll be negative 3 minus 1. And then we distribute this negative, so it'll be plus 2 pi. So our final answer is negative 4 plus 2 pi. I wish I left myself a little bit more room, but that is the answer. We found area. We plugged in a smaller number on top, so we had to negate the integral, so we did minus area instead. And when we found area, we were careful with our area formulas from geometry. Area above the line counts as positive. Area below the line counts as negative. Let's now do this question right here. G prime of negative 3, G double prime of 0, and G double prime of 3. Let's get started. So G prime of negative 3. Well, G prime is equal to F, so that's going to be F of negative 3. And F of negative 3, oh, so this is a hard question because it looks like we can't find, it's not a good value, if that makes sense. Like, it's not a solid line. But you can try to be clever with your slopes and stuff like that, or you can try to find the equation of this line. I'm going to try to be clever. It looks like our point is negative 1. This point right here is negative 1, 1. And this point right here is negative 2, comma 0. So if we want to find the y value at negative 3, that's just going to be midway in between. So that's going to be 1/2. Again, one way to do it is find the equation of this line. So you're going to do y2 minus y1 over x2 minus x1 to find slope. Then you plug in one of these points and you write it in point slope form. And then you plug in negative 3. But sometimes you can just eyeball it, especially because if it's not there, usually it's a half. And that's what I did there. So now I need to find G double prime. Well, G double prime, what is that going to be? Well, G double prime is going to be F prime of 0. And why is that true? Well, again, that's because G prime is equal to F, so G double prime will be F prime. And how am I going to find F prime values? Well, this time, because the graph is F, that's going to be slope values. And I need to find the slope at the bottom of the semicircle. And notice that we have a horizontal tangent line here for our graph F. So that means that our slope is going to be 0. Moving on, let's do G double prime of 3. So G double prime of 3 is going to be F prime of 3. Let's divide this from our previous work. F prime of 3, again, it's going to be slope. So it looks like it's the slope of this line right here. Again, unfortunately, we don't have a endpoint here, but it looks like we can do y2 minus 1, y1, or eyeball it pretty well. It looks like I'm going up 1, right 1, up 1, right 1. So it looks like this slope is just 1. So that is how you find these G values, G prime values, G double prime values. It's going to be area, and in this case, we had to do FDC, and the G prime values are going to be Y values, and the G double prime values are going to be slope. Just keep in mind that if they ask something like G double prime of 4, that would have been G double prime is going to be F prime, so that would have been does not exist. So now we're almost done because the next question shouldn't take too long. G has a horizontal tangent line. For some reason, students have trouble with tangent lines, but they're always the same. G has a horizontal tangent line. Let's talk about this, because that's why we're here. What does a tangent line entail? Well, a tangent line entails that the derivative of the line is going to be, the slope of the derivative is going to be the slope of the line. What does the word horizontal mean? Well, that means that the slope you want to be 0, because like you have a line like this. But keep in mind that this was a horizontal tangent line of F, but we want to have a horizontal tangent line of G. So we want the derivative, so let's write the derivative, to be 0. But what is the derivative? Well, G prime is equal to F. So that's going to be equal to F. So we want this to be equal to 0. So I'm going to look at my graph, and I'm going to see where's 0. And it looks like it's negative 2 and 2 and 6. So the answer is negative 2, 2, and 6. So that's my answer. Again, G having a horizontal tangent line will be very different than F having a horizontal tangent line. I'm not actually looking at tangent lines that are positive because this is, or tangent lines that are have horizontals, that are horizontal and have slope 0, because again, I care about G, and G is not pictured here, so I just had to find the zeros of this graph. Now the question asks whether, for what values does G have a relative min and a relative max? So you can tell that I made this worksheet and not, for example, College Board, because they would probably be more specific. They would probably say that we want to be on the interval from -4 to 6 without equal signs here. Basically, they wouldn't want us to talk about this point because we don't know if it crosses here, so just be wary of that. But let's do this. G has a rel min. So what's the rel for rel min? Or local min? Well, that's when G prime goes from negative to positive. Might as well write the rule for rel max, which is the opposite. That's G prime goes from positive to negative. Okay, so rel min. So rel min is when it goes from negative to positive. And what is G prime? I should have written G prime equals F, G prime equals F, G prime equals F. So we can maybe like squeeze a little equal F, equal F, equal F. Not my best work, but we'll go on. G prime equals F. So it looks like it's this one right here, because notice that G prime equals F is negative on this portion, and then it crosses the x-axis and it's positive. Keep in mind that we're not like finding rel mins of this graph again, because this graph is F, and F is not the same thing as G. So this one is -2. Now we're going to do G rel max. So what's G rel max? That's positive and negative. That's going to be this point right here, because it's positive and then negative. X equals -2. Oh, sorry. Don't know how to read math. This is -2. This is negative and then positive, so this is going to be 2. Negative to positive. So our rel, let's recap because this is embarrassing. So G prime equals F goes from negative to positive when you want to find a relative min of G. So that's this point right here. It goes negative to positive. It's past the x-axis, so this is the point 2. G has a rel max when it goes from positive to negative. So that's this point right here, which is -2. Similarly, let's do concave up. Let me try to redeem myself. Again, concave up always has 2 rules, G prime or G double prime, but I'm going to use the G prime rule because G prime is equal to F, and that's my graph. So G prime is equal to F is increasing is this rule. So I'm going to look where this graph has a positive slope or is going uphill. Looks like it's going uphill starting at this point right here, 0, and it's going uphill all the way up to 4. And that's the only portion. Okay, 2 questions to go. G inflection point. This is when G prime equals F goes from increasing to decreasing, or decreasing to increasing. Again, I don't like to write the rule G double prime changes signs because I'm given a graph of F and G prime happens to be F. So let's see that. So it looks like one of them is evidently this point right here, increasing to decreasing. So X equals 4 is an answer. And then it looks like the bottom of my circle is also, or my semicircle is also 1 because G prime is decreasing right here. And then it's increasing. Just keep in mind that at this point, the question asks us about the X value. And because this is on the Y axis, a lot of students will write 2 because like there's literally a 2 here. But that's the Y value. We want to find the X value. And because we're on the Y axis, that's going to be 0. X equals 0. More important, these are the 2 big questions in these sort of graphics. The first one is this FTC using areas, potentially flipping if needed, doing area correctly, like positive area is above the x-axis, negative area is below the x-axis. And then all these like increasing, decreasing, concave up or down questions are very important. And you should just get used to it where you can just do them and every question is the same level because you're not really doing any math, you're just looking at a graph. So for example, I can quickly do them. G is increasing when G prime is equal to F, so that's above where the graph is above the x-axis. G is decreasing when G prime is equal to F is negative, that's below the x-axis. G is concave up when G prime is equal to F is increasing, that's like this portion right here. G is concave down when G prime equals F is decreasing, so that's this portion right here, and also this little last portion of the graph, if you can see it. And then G has a rel max when G prime is equal to F, it goes from positive to negative. G has a rel min when G prime equals F goes from negative to positive. And then finally, G has an inflection point when G prime goes from increasing to decreasing or decreasing to increasing. So notice how quickly I can recite all 4 questions. And that's just because I have experience with these questions. But I'm also not thinking when I do the questions. I'm just looking at this graph and like just seeing various components of this graph. I don't have to like do crazy areas or like do base times height divided by 2 or take antiderivatives or derivatives. So I try to like savor these moments to do these easy questions because they're not too bad. Okay, but let's do a bad question, which is this question right here, absolute min. So absolute min is, when I teach this, I don't have this appear the first time I introduce it. I do it later on, basically this moment right here, because it is kind of confusing. But we're going to do our 3-step process like normal. We're going to do locate. So unlike our previous question, notice that in our previous question, we're trying to find the max and min of G, but G was just given to us for free. In this case, G is not given to us, so we have to construct it. But we already found G values. We found G of 6 here. We found G of -4 here. So what we're going to do is we're going to do the same thing. We're going to do FTC. So we're going to write G of X, and we're going to use our given point from before. So again, they give you this point to do FTC, to do G values, and also to do G values when you need to do abs, max, or min, and that's when you use this given. It's going to be the given Y value, which is -3. And then we're going to put the given X on the bottom, so that's 2. And then just keep in mind that some students like to put like 6 here, or some students like to put -4 here, but you just keep it as X. And then you're going to write this, write the derivative, and that's going to be F. And just keep in mind that when I do these questions, I'm very careful with my variables because I always want to plug in to the top variable here and not to any of these variables, for example. So I never want these variables to match. So notice my X is not the same thing as my T's, because again, I'm going to plug in only to the upper limit. This is different than rate in, rate out fricks and particle motion fricks, where in those fricks, because you're finding like the amount at time or position at time, you put the T on the top, so then you change them to X's. You just don't want them to match, these variables to match. You want this one to match whatever you're trying to find over here, and then you want the ones in the integrand, or the constant of integration is what people call it, to not match the upper limit here. Okay. With that being said, let's do the second step, which is my favorite step. There's just critical points. You take the derivative. What's the derivative of this integral? Well, the derivative of -3 is going to be 0. And how do you take the derivative of an integral? You use fundamental theorem of calculus, of course. So all you do is you take the x, plug it in, so you get f of x. And again, we've been talking about this construction from the very beginning. G prime equals f, G prime equals f, G prime equals f. We're going to still set it equal to 0 because critical points we need to find where the derivative is equal to 0. So we're going to look at our graph, and it looks like it's going to be -2, and it's going to be 2, I think. So actually equals to a -2. Almost done, but unfortunately we have my least favorite step coming up, which is the table. Let's think about what we want to plug into this table. Well, it looks like we're going to include our endpoints, of course. And then both of these critical points fit within those endpoints, so -2 and 2. Question is, what should be the right side of my column? Well, the right side of my column is going to be G, because it's always the locate function. So what we're going to do is we're going to individually plug in these 4 numbers into just the top, because again, we're just plugging it into the X. And what we're going to do is we're going to find the area from this number to whatever number we plugged in, and we're going to add -3, which came from the FTC. Luckily enough, we already found G of -4 and G of 6, so I'm going to copy those answers down. G of -4 is -4 plus 2 pi. And then G of 6 is equal to, where is it? I can't even read my own handwriting. It equals 1. But again, if I wanted to find it again, I'd like, for example, plug in 6, and then I would do the area. Positive areas above the x-axis, negative areas below. Then I would add -3. And just remember that when we plugged in -4, we had to do negative area because this, the top number was smaller than the bottom number. The next easier number to plug in is 2, actually, because again, when you plug in 2, there will be no area between 2 and 2, so that's just -3. We still have to do the -3 plus 0. So it looks like all we have to do is -2. So let's just do it on the side, because this is the last sort of part we have to do. So we'll do it in the top here. -3 plus -2, 2 of f. Just like we did at the very beginning of this question. So notice that our our top limit or our upper limit is -2, and our bottom limit is 2. And -2 is smaller than 2, so this is the bad scenario where you have a smaller upper limit than a lower limit. So what you do remember is you negate the integral, but a lot of my students stop negating the integral, they just write minus area instead, and that's what I'm going to do. And I'm going to be careful when I do this area. I'm going to put it in parentheses. So again, you always find the area between the 2 points. So we put in -2 and 2. So it looks like it's just the semicircle. We already found the area of the circle before. That's 2 pi, because it's pi r squared. The radius is 2, 1, 2. These 2's cancel, so you have 2 pi. But again, when we do this, we have to be very careful with negatives. There's so many negatives in these questions. Negative from the flip and also negative from the negative area, because notice that this semicircle is below the x-axis. So we're going to put -2 pi here. So notice that when we sort of simplify, we're going to distribute this negative, so it'll be -3 plus 2 pi. And that is our final number in our table. So time to find the absolute max and the absolute min. So this is, again, kind of tricky because there's pi's, so it's kind of hard to tell which number is bigger than the other numbers. But the only thing I know is pi is like 3.14. So 3.14 times 2 is like 6.28. So 6.28 minus 3 is going to be our biggest number probably, because it's definitely bigger than this negative number. It's bigger than 1. 6.28 minus 3 is like 3.28-ish, and it's going to be this bigger than this one as well. So our abs max is -3 plus 2 pi, and that occurred at -2. And then our abs min is -3. That's going to be our only negative number after we do this at x equals 2. And that's GraphRix for you. Again, GraphRix, let's just recap. I probably won't do rate in, rate out and particle motion. I probably would just keep it to this worksheet. So I'm just going to talk a little bit. But GraphRix come in 2 variations. The first variation is an f prime graph and an f of a equals a number, which is a point. And the reason why is that you need to do FTC at some point. When you're doing this variation, the rules are just the normal rules. And just be aware that all the rules are going to include the derivative, whether that be f prime or g prime equals f. For the second variation, you're already given an integral, so you don't have to construct FTC ever. But you have to know how to find g values, g prime values, and g double prime values. G values are area, g prime values are going to be y values, and then g double prime values are going to be slope. Whenever you have this variation, when you ask your increasing questions, concave down questions, concave up questions, realm min or max, inflection points, and so on, you have to use g prime equals f as the rule, and you just say like g prime equals f, blah, 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 blah. And then the most annoying question is probably as max or min, but we still do it the same way. The locate's a little bit difficult, but this is how you locate the function. You find the critical points, and then you construct your table. As you're constructing the table, you take these numbers, and you plug it into the integral, and you usually find an area. In this variation, you just simply find area. And then in this variation, you do have to do the number plus integral part. So number plus area or number minus area. And how do you tell? Well, again, if the upper limit is bigger, you do plus, and if the upper limit is smaller, you do minus. And that's how you do GraphRix. GraphRix are the most commonly found frick on the AP exam. It's usually the first non-calculator frick because you can't type a graph into a calculator. So it's one of the most important fricks. And it's also my favorite frick because you don't have to do very much math besides finding areas potentially. Especially if you know your shapes and curves rule, which are the rules of like increasing, decreasing, realm min or max, and so on. But hopefully this was useful for everybody. It's been 50 minutes, which is a little bit longer than I expected it to take. But it's always fun. Next week we might be back and we might be doing similar stuff to review for things. But we will see. But hopefully that you found this useful. And thanks for watching.